The overall goal of this experiment is to directly detect solvated electrons in the plasma-liquid interface.
This method can help answer important questions regarding the free radical chemistry created by a plasma in contact with an aqueous solution.
The main advantage of this technique is that it provides direct measurement of a short-lived free radical, the solvated electron, through its absorption of light.
The implications of this technique extend toward medicine, as low-temperature plasma is now being tested as a form of cancer treatment.
This method can also provide insight into chemical synthesis techniques, as low-temperature plasmas are used in many industrial processes.
For this method, use a custom plasma electrochemical cell 2 inches in diameter, with 2 optical windows at angles of approximately 20 degrees down from the normal plane. Use a well-fitting PTFE cell lid with 4 ports for the electrodes and gas lines. Use an anode made of a piece of platinum foil attached to a stainless steel rod, and a cathode made of a sharpened stainless steel capillary. Use as the absorption spectroscopy light source a 670 nanometer diode laser, in line with an adjustable iris and a 50 mm lens, all mounted in a 30 mm optical cage system mounted on a goniometer to allow adjustment of the angle of incidence. Use as a photodetector a large area photodiode wired in a reverse bias leakage circuit, with a 670 nanometer bandpass filter in front of the detector. Mount the photodetector on a second goniometer. Ensure that